This is part 2 for chapter 11.1, hypothesis testing regarding two proportions from independent samples. And so in this case here, what we're looking at is in your note sheets, the second page, you have the steps like I've provided previously for chapter 10. You have all these steps, and you can see if we had to do hand calculations, it would take us a long time. That's why I prefer StatCrunch. You can see we're going to have two proportions, so you end up with a P1 hat, a P hat 2. You have to compare. You have um, the standard deviation. You have a lot of calculations that need to be done by hand. A lot of room for mistakes. So that's why we use um, StatCrunch to do this. And then looking at the hypothesis regarding the difference between two population proportions, we have some assumed conditions that need to apply before we can actually use our test. And so you have these you'll notice the same types of tests. Sample size has to be less than 5% of the whole population. You have to do that multiplication, n times p times 1 minus p, but now you have two samples, so it takes some time. Here are the notations here for the types, how we're going to write this, P1, P2, the first proportion versus the second proportion. So we label it P1, P2 because we have two samples. And if we use the p-value approach, if we were going to do it by hand, same idea. We calculate a test statistic. StatCrunch will do that for us, but you can see where there's room for a mistake. There would be a p-hat. This is, you end up kind of what's called pooling it, but again, we're going to use StatCrunch to do that for us. And then we do StatCrunch, and then we check to see if the p-value less than alpha. If so, reject the null hypothesis. Then you go ahead and state the conclusion. Okay, so it's the same exact stuff. We just got to make sure we set it up correctly. So let's just go ahead and do an example, right? So you have on your note sheets, you have this here. Here's example 1. Go ahead and take a read at that real quick. So as you take a look at it, the first thing you should be able to come up with, and I wrote them in already, are the proportions for the two samples. We're comparing two samples, and now we want to use those samples to determine if those two population proportions are the same or different based on the claim here. And so in this case, an economist believes that the percentage of urban households with internet access is greater than the percentage of rural households. There's the claim. And so we're going to test this. And so just to kind of go through the process, this is a two sample proportion. You have to ask yourself, which type of test is it? Right now we're in a two sample proportion. Right now the claim is that urban has greater than rural. I could say that. That's the claim, right? Believes the percentage is so the percent of rural is greater than the percent of urban is greater than rural. That is our claim. And it looks like if you do the calculations that possibly that's true, if we do the decimals for those. And so we'd be comparing them. And so in order to start, we would need to write a hypothesis, what significance test, what level of significance, what test type is this, and then we use StatCrunch to get the test statistic, the p-value, then make a decision, just like we've done before. So looking at that again, so our null and alternative is going to be one of these things. So more than likely in this case, we're saying P1 is greater than, so that's the one we would be doing right there. It would be a right tail test, and so that's what you would be writing in for. That's what you would be writing in for that one right there. And so you run the two tail tests. Let me get to that example so we can actually see it on the PowerPoint. We'll get there. We'll decide if P is less than alpha. We reject the null hypothesis. State your conclusion. There's the test. And so the first thing is going ahead and calculating the p-hat for one is 0.42. The other one's 0.30, 0.4225 and 0.3895. So those are our P1 and P2 right there. Those are our values that you would put in there. 0.4225 and 0.3893. That would be for the first one. And then we're comparing if P1 is equal to P is the null hypothesis, P1 is greater than P2 is the null hypothesis. We would have that. Now in StatCrunch, if you got to be careful here. So this is what you would be writing for H1, H0 and H1, and this here is what happens in StatCrunch. StatCrunch has you write it differently. So as soon as you write it this way, this is the way it looks in StatCrunch. So this is what you should be writing down right now. You have your P's, P1, P2. You should have this already. Here's your null and alternative. Our claim was that urban is greater than rural. We're testing this at the alpha 0.05. This is a right tail test. And now how do we get test statistic and p-value? You go ahead and StatCrunch it. So we're going to go to StatCrunch. This is a proportion stats 2 sample with summary data. On the first case we had for urban we had 338 over 800. For sample 2 we had 292 over 750. Hypothesis test P1, and then P1 minus P2 is greater than. So in this case, again, P1 minus P2, you might be confused here a little bit. How come we wrote it that way? Again, where that comes from, it comes from right here, a little algebra on the side here. P1 is greater than P2. This is the same thing. This is the same thing as, you got to remember your algebra. They are equivalent statements here. This P1 minus P2 is greater than 0. The reason is they're the same statements, is that if I subtract P2 from both sides, I get P1 minus P2. P2 minus P2 is 0, and so that's why they're equivalent. You're going to see that. You got to get used to it. You better ask for help if you don't get it. We're going to continue to see that. So we're going to run the hypothesis test just like that. Compute, and then you get a test statistic of 1.33, 0.092, 1.33. Our test statistic is 1.33. Our z-value, 0.092. What's our decision? We do not reject. Do not reject H0. Since, why not? Since 0.092 is greater than 0.05. Do not reject. What does that mean? That means, so what did we just do? We do not reject this. So we are saying that we believe this could be true and that this is not true. We're rejecting that. By not rejecting this, we're rejecting that. There is not sufficient evidence. There's not sufficient evidence to support the claim in this case, the claim that urban, the percent of urban is greater than the percent of rural. And so that's what that would mean. And so now we finish that and we conclude it. And so we're saying, based on the sample data, even though this proportion was bigger than this proportion, we do not have enough evidence to conclude that they're statistically different. And so then the last thing we add in chapter 11 is that we could actually conduct these types of, we can actually also do a confidence interval to actually determine that. And so in this case here, so we're going to add that P, it'll be the last piece. What happens is, instead of running a hypothesis test, we can actually run a confidence interval. We can do a confidence interval for this. And then you're actually comparing to see, are the difference between these two actually 0 or not. Remember, that's what the null hypothesis is. So you run a confidence interval, compute it, instead of and then you get two values here, upper limit and lower limit. I get negative 0.02 for the lower limit. negative 0.02. This is a 95% confidence interval. And then on the other side, we get, on the upper limit, we get 0.08. And so we can actually conduct a confidence interval test on this also by comparing the proportions. And when we compare the proportions, we're 95% confident. We're 95% confident that the difference between these proportions is either between negative 0.02 and positive 0.08, which means that it could go either way. Actually, one can be greater than the other, or the other one, or vice versa. And so in this case, what does this mean? So we're going to make a conclusion here. We're going to say we do not reject. This is an alternative way. Do not reject H naught, because H naught says that they're equal to each other, which means their differences are equal to 0. We do not reject 0. We do not reject H sub 0, the null hypothesis, because the 95% confidence interval, here's the key word. I'll write it in a different color. Because the confidence interval contains 0. Means 0 is in between it, which means it is possible that those two proportions are equal to each other. If this confidence interval did not contain it, then we would say it can't be equal to 0. They can't be equal to each other. So that's what we're looking at. We'll do one more example. The point estimate of this confidence interval, we go back to what we learned prior. That's a difference of 10, add 5, so the point estimate is 0.03. That's right in the middle. The margin of error is 0.05 for this.